Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. Our guest today is Dan White, EVP Americas Region for Satellite Ground Network Services, Swedish Space Corporation. Well, here we are on the floor of Satellite 2020, looking around, going from booth to booth, see what's going on. In this particular interview, we're going to discuss the future of networked antennas and global satellite constellations. And what a great guest we have for that. Dan has a bachelor's degree and a master's degree in electrical engineering, and on top of that, 30 years experience in engineering and program management within the aerospace industry. Dan has been with the Swedish Space Corporation since 2017, and we told you his role. He's EVP Americas Region for Satellite Ground Network Services for Swedish Space Corporation. He is responsible for sustaining and growing the customer base within North and South American markets. Dan, you having fun at the show?
Absolutely, having a great time.
I've just reread that. Within North and South America, that's a pretty big area. I mean, that's everything.
Yes, it is.
Pole to pole.
Well, we have a few people helping us, obviously, but there's a lot of activity in the U.S., and then Canada is obviously evolving, as well as Latin America.
Yeah. Well, the way I understand it, I went to your website, I think the Swedish Space Corporation designs ground communication network solutions that support aircraft on lunar missions. It seems that SSC has been involved with lunar missions since the Apollo program back in the 60s. Can you talk about this journey a little bit?
Sure. So we started supporting Apollo from our site in Santiago. And we were a backup communication to the module all the way to the moon and during its orbit and return. And so, the Apollo mission ended in the 70s. So we continued supporting various agencies around the world with science missions and research missions to the moon. And most recently, we did the Space IL mission, which is a commercial mission that went all the way to the moon about a year ago and unfortunately crashed upon landing. So that being said, for maybe 50 or 60 years, we've been supporting various levels of lunar activity with our ground network around the world.
From a retrospect, if you're looking back, so what's changed since the 60s?
Well, I would think what we're seeing today is the technology has certainly changed, and then the desire for data. Just like you have on your phone, 10 or 15 years ago, you didn't know all of the information that you could put on your phone and all the applications you could use on your phone. So now people are seeing, when they get into LEO and GEO and to lunar, the demands for data and information are much, much greater, which is driving data rates. So where it was kilobits per second in the 60s and 70s, it's megabits per second now in some of the requirements we're seeing. And so, again, SSC is well positioned for that. We have lots of large assets around the world at our sites, up to 13-meter antennas that can provide both TT&C communication and mission data communication at the lunar surface.
So we got the need for speed, we got the desire for data.
That's exactly right, and we try to solve both of those.
They're both pretty hard problems. So, look around, the trade show floor here, a lot of different companies here. What kind of a company would be looking for lunar communication services? Are there commercial and business applications so far?
I think today it's mostly, the institutional organizations looking for science, some research. Certainly the, NASA and ESA are now participating in the Gateway program, and so you can see this as a stepping stone for the work that we're going to do on our way to Mars. But I think all of that will lead to commercial opportunities where commercial organizations will be needed to supply goods and services, maybe shuttle people to and from. Maybe there's opportunities to do tourism, to the moon's surface and back. So I think in the next 5 years, we'll be establishing the gateways, and then in the 5 years beyond that, more commercial opportunities.
Well, back in high school, I learned Roman history, and they talked about Cisalpine region for ancient Rome. Now there's something called the Cislunar Orbit. Is that something that's out there? What the heck is that anyway? The
Cislunar, I think that's just beyond the lunar orbit. And so we're doing missions at the Lagrange points as well. Mm-hmm. And again, those require the big, large apertures so you can support the data rates required.
Now, your company is currently developing technology for a new flight ticket service for suborbital space flights.
Yes.
Can you tell me how this would work and why someone would be interested in using this service?
Sure. That's our Suborbital Express program. And so what we've done is basically taking the payload capacity of a rocket and tried to partition that into smaller units and call it call it smaller pods that can be distributed to different places on orbit. And so we try to sell that to basically fill up the entire payload capacity with more than one customer to provide flexibility. We believe that the whole goal of the launch industry should be to provide flexibility for people that need to get to space in an economical manner. And so we're trying to divide up the 800 kilograms of payload into smaller chunks so people can share missions.
And I think, you walk around the show, you see small sat vendors, different types of satellites giving out there. I mean, you really have to be more flexible. I think this is the word, I think, from the 1960s.
Yep.
It's the word flexibility. It's
yes.
Like back in the 60s, we did it this way, and this way it worked. Now it's 10 hours, 10 different flavors.
Yes. Yeah, I think flexibility is the key, and that's we're trying to be as agile and flexible as we can, both on the satellite ground side, supporting lunar, as well as our Suborbital Express, where we're going to provide launch capability within the next couple years.
One of the biggest industries facing most of the people at the show is launch. So
Yes.
how can industry make them more affordable and readily accessible by others?
Well, it's really about, as you said, flexibility, agility, and cost. We're seeing lots of efforts with new rocket launchers coming in. They're much more competitively priced. I think they're targeting a lower payload capacity. We're not building rockets to launch 6,000 kilogram payloads anymore. We're talking 300 and 400 kilogram payloads. You're seeing lots of success in that with companies like Firefly, Electron, Rocket Labs. And so I really think it's about cost, access to orbit, and the flexibility of companies to develop that service.
Everyone can take and say, yeah, we're flexible, we're agile, we can adapt and change and look at situations and change in the next 2 or 3 weeks. But, there's always challenges in that area. And so what are the challenges here for the ground stations? How can they be relevant in the future?
Well, I think we really have to pursue higher data rates. As we talked about on the moon, we're seeing higher data rate requirements everywhere we look, and it's really the need for information. Once you get in space and you have an asset in space, you spent a lot of money and risk to get it in space. You want to get as much information to the ground as quickly and economically as possible. So we're looking at higher frequencies. We're looking at different technologies, things like optical, different modulation characteristics to basically put more data in the data stream.
Obviously, the company's based in Sweden. Is there any particular advantage they have to being that far north, or having the government behind them like that? There's got to be some advantages in that.
Sure. The S-Range Space Center, which is our flagship site, that was the original site of Swedish Space Corporation back in the early 60s.
Oh, it's hashtag ESRANG. That's what the hashtag is.
Yeah, that's what the hashtag S-Range. And so, because it is polar, if you're launching sounding rockets into a suborbital polar orbit, that's a great location from which to do it. That then transitioned to ground communications, and if you are trying to track a polar satellite, having a site above the Arctic Circle allows you to catch every orbit as that satellite goes around the world. And so there might be 16 orbits, and we can see about 15 each day, which is very economical if you're trying to maximize the amount of time contacting the satellite.
I went to your Twitter feed at SSC Space, and I saw hashtag S-Range, and I didn't know what that was.
Yep.
I also saw hashtag Access to Space. Now it makes sense what you said in the last 10 minutes. It all puts together, doesn't it?
Yes, exactly. We're trying to work our social media.
There's some method to the madness here, huh?
We hope so.
We know, Dan, thousands of people from all over the world have listened to this podcast. You can go to Google and type in Constellations Podcast to get to our show notes page. Here, you can get transcripts for all 71 interviews. Also, you can sign up for free email notifications for future podcasts. Listen to folks like Dan talk about satellites from Sweden and everything else. So, Dan, how do you think ground stations should adapt for payloads?
I think that we have to really go back to the higher data rate. We have geographic locations around the world. I think we have that fairly well covered. We can capture most satellites most of the time, satisfying our customer needs. It's really the desire to get more data down on a given pass, and the only way to do that is with higher modulations, higher frequencies, or different technologies. And so we're pursuing all three at this time.
All three? That's hard to do, isn't it?
Yes.
So what kind of requirements should ground stations anticipate here in the next few years?
I think you can see that they're going to want both RF and optical capabilities. Optical can allow you to get more data to the ground. The RF is a good backup in case there's a cloud in the way, and the optical telescope can't see the satellite. I think it's flexibility and agility. We need to be able to address our customer needs. When they put new satellites in space, we want to be able to I'll say onboard those satellites to our network in a very easy way, and it can't take weeks or months. It needs to take days, hours or days to get into the network. So we're looking at sort of common standards to integrate into our network. We're looking at common schedulers to make access to the capacity easy, and then we're looking for technologies that drive higher data rates so we can get more data to the ground quicker.
In the United States, trucks always have LTL, less than load. It's almost like you have a 53-foot truck here, and you're trying to be absolutely flexible and use all those, all that sense you have to fill up that truck. But you're trying to fill up the payload here, huh?
We have 1,440 minutes in a day, and so that's all an antenna can look to a satellite. And so we're trying to make sure that as many minutes as possible are full on that antenna. So you have to know where the satellites are. They're in an orbit, and so you can only see one satellite at one time. To that end, I guess I would talk about we're also looking for multi-beam antennas to be more flexible so that a given aperture can connect with more than one satellite at a given time, which again will help get more data to the ground quicker. Yeah,
1,440, optimize them. I think most people are trying to optimize them in their own life.
Exactly.
You're trying to know something else. Let's talk more about optical here.
Yeah.
So do you see it becoming more relevant?
Yes, absolutely. It's you can generate higher data rates with optical. The technology is it's being developed. I wouldn't say it's 100% mature yet, but we have a partnership with Bridgecom to install 3 of their optical terminals at our sites around the world, and then we would basically offer up an RF solution and an optical solution to those customers to, again, maximize the amount of data and the reliability of that data coming down from space.
Again, optimizing, like the mathematicians say, optimizing those numbers and giving choices and options for them.
Maximum efficiency to fill the capacity is really our goal in life.
Well, we just touched on optical. What about phased array antennas?
Well, phased array antennas, I guess I would look at more multi-beam tracking antennas it's not mechanical tracking but electronic tracking antennas, and absolutely we're looking at those because if you only have so much real estate, you want to try to get as many satellite beams out of that given aperture as you possibly can. And so a phased array fits into that. It fits into that need. The challenge today is the cost and performance that you're getting out of phased arrays. So we're working with some antenna manufacturers today to see what might be available, where their roadmaps are going, and how that might fit into complementing some of our parabolic antennas that we have in the field.
Let's talk about complementing optical networks. We'll go back to those. I mean, how do you go about doing that anyway?
Well, so we would basically at the same site, you'd have an optical ground station and you'd have an RF ground station, and both of those would be connected into to our network. They'd both be scheduled into the network, and they would both basically track the satellite, and if a cloud came in the way, the optical wouldn't work, so you'd be getting less data down. You'd switch over to the RF, still maintain a data stream, albeit at a lower rate, and again, maximizing the amount of data transfer during a given pass. And so we would basically just integrate optical and RF into our network.
Now, I'm in the world of software development, and they talk about software maturity models, and at a certain point in software, this is what happens. And when I look at your company, I was at your website this morning, it talks about the world of advanced space services. Well, you don't get advanced unless you've been there a few decades and can understand what's going on. And really many of these topics we talked about, this is the big leagues. I mean, this is really high dollar value, high volume, and optimizing this at a very high level.
It is rocket science.
Yeah, I guess it certainly is. It's advanced and it's difficult. So speaking of difficulties and advanced difficulties, where do you see the future of satellite systems?
I think that you're going to see more and more sort of Earth observation, space situational awareness. I think once as you get more and more objects in space, people will want to know where are those objects, what are those objects doing. I think as climate change happens on Earth, we're going to want to monitor and look at mitigating some of those changes, and so you can do that from space much easier than anywhere else. I think telecommunications is certainly important. You're seeing the mega constellations like SpaceX and OneWeb and Starlink and Amazon that try to provide ubiquitous communication across the globe. And then ultimately, we're going to be going beyond the moon and we're going to be going to Mars. And so everything that we do day to day on Earth is going to happen on that trip to Mars. So there's going to have to be space systems that support that. And that could be, docking, in-service refueling. Maybe it's even people transfer. Maybe it's taxiing. Who knows? But I think it's continuing to evolve. It's a fascinating industry.
Let's go from Mars back down to GEO here.
Yeah.
So how do you see the future of tracking objects that are out past GEO, just a little bit or very, very far out there?
Well, we don't do too much of that, but I think that people will always want to know what's going on sort of inside the GEO belt, and as we now go closer and closer to the moon, we'll want to know what's going on closer and closer to the moon. So technologies exist with both radar and optical, where you can track those objects. We don't spend that's not really our business line right now. Although we are investigating tracking some objects in the LEO regime, because there's so many satellites being launched in LEO in the next decade. We think that there's a concern there with the amount of debris that it potentially creates.
I used to write down the number, but I can't write down the number anymore.
Tens of thousands.
Yeah,
tens of thousands.
Many.
Yeah.
This is one of the things where you have well-respected experts come up with a number, another number, and you go, well, it's going to be many, huh?
Yeah. To go to current events, if it's like coronavirus, today there's 500, tomorrow there'll be 700.
Who knows? Nobody knows. Well, Dan, unfortunately, we are running out of time. I'd like to thank our guest, Dan White, EVP, America's Region for Satellite Ground Network Services at Swedish Space.
Thank you, John.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.